Okay.
And so we are now recording.
All right, so I guess we're going to start this a little bit early. And
Well, let's give them a couple minutes to come in.
oh, good. That'd be better, yeah. By the
Yep.
way, you can unmute people if you want. Let them ask some questions beforehand. I always like questions better than just sitting here talking to my computer and don't get any interaction.
Robin, you're getting a little low in volume.
Okay, I'm not sure what I can do about that.
That's
Maybe I
much
got a
better.
volume control.
That's
Oh, really?
much better. Yep, that's much better.
All right, all I did was set up. Anyway, it would be nice to get some questions even beforehand. We can certainly have questions after or during. But if anybody has any questions about our pre-wired system, I would sure like to have them show up.
Okay, I am unmuting everybody
Great.
so we can hear people talk.
Hi, everybody. Everybody want to say
Can
hi?
you hear me? I'm here.
Hey,
Hello,
Kim.
it's me. It's Kim.
Oh, hi,
Hey,
Kim.
Robin, are you going to go over the what we're doing with SMA stuff today?
Yes, yes, a little bit. It's a little bit of everything, not a in-depth on anything, unless somebody wants to go in-depth, and then I'll go as far as my knowledge allows me to.
Well, but just to let everybody know about the revisements that we're doing. No SMART, no 2-to-1.
Yeah,
Just
I will
that
talk
kind of
about that.
Good.
I don't have anything presented on that, but we can certainly talk. I'll talk about that right now.
Just a heads up, yep.
The SMA Sunny Island inverter, which is a very, very good inverter.
Yep.
I wonder why this keeps on coming up. But like all inverters out there are some warts. I can't name a single inverter that doesn't have wart. One of the warts that, it's not a wart, it's just a lack of a feature about the Sunny Island inverter is it's only got one AC input. Now, some of the other guys, Xantrax or Schneider, the new Radian, even some of the new Magnum stuff, they've got two AC inputs. And it makes life a little easier when you want to be on the grid and have a generator. The other ones are also 240-volt systems, which makes things a lot easier too. We built this thing called a SMARB, SMA relay board is what that stands for. It's got 3 100-amp contactors on it. But we've found the hard way that very few people out there are qualified to install it. So, and bad things can happen with an SMA inverter when it's not installed properly. In fact, bad things can happen even when it is installed properly. The SMA is actually capable of selling power back to a generator unless it is set up properly. And that's not a simple task. It doesn't come out of the box set up properly for that. So we have elected to discontinue the SMARB. If we get a lot of pushback on that, we can certainly consider it on special circumstances. But we've been spending hours and hours and hours trying to support the SMARB, just because a lot of homeowner installed guys can't do it. And they're breaking inverters or breaking relays and spending hours and hours and hours of our time. I think a better way to get over this is just to have a manual transfer switch. That way you can't backfeed the grid, you can't backfeed the generator. It's just not as elegant. So we tried something that actually works quite well when done properly. It's become a support nightmare. So we're going to drop the SMART. Okay, that's it for the SMART. We may as well get on with this. Rachel, do you think we should actually start this?
Yep, let's begin. Oh, we do have some questions already starting. So.
Oh, great. Let's ask some questions.
I-
Who's got a question?
Oh, just everything is echoing in double. So do you have?
If you mute everybody, I think that goes away.
Okay, we'll mute. How's that? I muted everybody. Did I mute? Robin, you still there? There we go. You still there, Robin?
Okay. I'm here.
Apparently when I clicked mute all, it also muted you.
Okay. So people can type in their questions.
Yep.
Or you can unmute them to ask a question, and we'll put up with the echo. So who had questions?
Well, taking me just a minute. Nope, it's no questions. You can begin speaking.
Okay. So we'll start with, we're just going to go through a few slides here of some of our systems, and then we'll go to our website so I can walk you through a few of the systems and some of the information available on these systems. They can get quite complicated. This is especially useful to buy a pre-wired system if you're not familiar with battery-based stuff. So, of course, we sell these to Joe Consumer, through dealers, which would be the people attending this webinar, or through websites. People can build their own rather than buying a pre-wired. That's when we get lots of phone calls. We're used to phone calls. But as a professional installer, there's more and more grid tie installers getting into battery-based systems now, just because a lot of the pushback from the utilities are on grid tie. So battery-based is seeing a resurgence of sales. And they are 10 times more complicated than the grid tie system. Or so I've been told. I've been dealing with battery-based systems my whole life, so I don't know anything about a grid tie system, to tell you the truth. But battery-based systems aren't that tough. Getting a pre-wired system makes it really simple. It is as plug-and-play as is possible. So here we're looking at a 240-volt AC-coupled Sunny Island system. So it's really designed to match up to a 6,000-watt Sunny Boy. I did put all the retail prices on these slides, by the way, so don't let the $10,000 scare you. That's what the Joe Consumer has to pay, minus any discounts that are given. Dealers are going to pay, what, 30% off of that or whatever. Now, because of the Sunny Island is only a 120-volt inverter, and it matches up with a 240-volt grid tie inverter, which doesn't have to be a Sunny Boy, by the way, but it works better when it's a Sunny Boy. We had to add the autoformer. That's the top box up there. And we actually use the SMA autoformer in Poland in the SMA-owned factory. The box on the very bottom is our E-panel, and there's a little inset of what's inside the E-panel. There's a lot of different E-panels we have for the SMA equipment. About 6 different model numbers. But when it comes to pre-wired systems, there's about that many too. There's AC coupled versus off-grid. Off-grid, the main difference is going to be the charge control. So this is probably one of our most popular AC coupled systems. There's a dual system. So if you've got a couple of Sunny Boys or other inverters, the best way to deal with it is to have 2 Sunny Islands. And now you get 240 volts. You don't need an autoformer. There is another way to deal with it, which we also found very, very complicated. And I think we're not going to continue on with that. But it would allow you to put 12,000 watts of Sunny Boys into a 6,000 watt Sunny Island. Doesn't seem to make any sense right off the bat. and it certainly did cause lots and lots of problems. It can be done, but when it's all said and done, you're really better off to have 2 sunny islands. It does cost a little more, but you will not get callbacks. Now, on this particular slide, we didn't show the bottom yellow covers, but yes, they do come with it. This would be shipped in 2 different crates. They are fully tested. It comes with the conduits, so we give you directions on the mounting spacing to make the conduits work out. Of course, if that doesn't work for you, if the studs centers aren't what we say they need to be, you can cut the conduits down or lengthen them. The wires are already provided. They're coiled up inside of one of them in the master, I guess.
Hey, Robin. We have some questions.
Oh, great.
The first one is, I have a midnight pre-wired dual Schneider XW system. Also, I have an in-phase microinverter, 6-panel separate array. They are located on 2 different buildings wired to the XWs. I understand with AC coupling that when the grid goes down, the in-phase microinverters switch to sending the power to the XW system, charging the batteries. My question is, what happens when the batteries are charged or SOC is at 100%?
Okay. Well, the in-phase inverters on an AC coupled system is always sending its power directly to the output of the XWs. And then through the input terminals of the XWs, it goes back out to the utility. So what happens when the grid goes down? Obviously, the relay inside of the XWs opens up, so there's no way you can send power back to the utility. But since the in-phases, or any microinverter, are actually connected up to the output of the XWs, which just happens to be a perfect sine wave, the in-phases don't know the utility is down. So the in-phases keep on producing power. The XWs produce power for the house on their output, and also they are charging the batteries. Now, other than the sunny island, that's the only battery-based inverter that has a coordinated charge with the grid tie inverter. And it has to be a sunny boy inverter and a sunny island, and you've got to have a communications cable. But when you're dealing with in-phases, this is very, very popular for AC coupling. How the XW deals with it, and in-phase doesn't like this, but I kind of like it. The XW, as the voltage on the batteries rise, so let's say you have a 48-volt system, as the battery gets up to 56 volts, the frequency that the XW puts out starts changing. Instead of 60 hertz, it goes up to 60.1, let's say, and I'm going to make these numbers up because I don't have the exact numbers. As the battery gets to 57 volts, it goes up to 60.2 or 60.3. And finally, and these are all user settable, by the way, as the batteries finally get up to, let's say, 58 volts, and let's say that was the maximum you ever wanted those batteries to get to, then the XW is going to switch frequency up to 60.5 hertz. And at 60.5 hertz, by law, the oh no, this isn't anti-aliasing, but at 60.5 hertz, it knocks. Yes, it is by law. It knocks the in-phases offline, because the in-phases, other than in Hawaii, where they have to work all the way down to 57 hertz, they have to be shut off at either 59.5 hertz or at 16.5 hertz. And this is called the anti-islanding part of the UL. So what happens now when it goes up to 16.5 hertz and the in-phases get knocked offline? You quit charging the batteries. It's an uncontrolled charge using the XWs, but they do have this nice feature of frequency shifting. So it doesn't overcharge the batteries, and it won't reconnect until the battery voltage drops down a bit. In-phase would rather see a relay in between their in-phase inverters and the battery-based inverter. They haven't investigated the frequency shifting, therefore they're a bit skeptical of it. Schneider says it works great. They got it ETL or UL listed, CSA actually in that case. So you can add a relay if you would like, if it's going to make in-phase happier. When we do these systems, we do typically add a solid-state relay. And then it's guaranteed you've got an actual disconnect switch rather than just frequency shifting. Did that answer the question?
I do believe it answers the question, but then there's also sort of another part that this person mentioned. And it says, I'm using 2 classic 200s to charge the batteries. I have the XW's AC charging disabled, and he can add more if you want to comment.
Okay, so he's using DC coupling, and he's got the N phases connected up to the output of the XWs. Is that correct?
He says yes.
Yeah, okay. So, well, as long as the classics or any other outboard charge controller is set to some high voltage disconnect. I mean, it doesn't really disconnect when it's a charge controller like the XW does. But you're not going to overcharge the batteries. Let's say it was also set for 58 volts. So let's think about this. The grid goes down. The solar panels going through the charge controllers are just going to charge the batteries normal. They're not going to overcharge it because that's their job. The XWs, which are AC coupled to the in phases, they're going to knock the in phases offline because that really is uncontrolled charging, other than the fact that you've got the XW's frequency shifting. And that is now your, we call it a bang-bang charge controller. It's on or it's off. But it's there just to protect the batteries from being overcharged. It'll work just fine. And frankly, very few times during the day of that power outage are you typically going to be banging the in phases to turn them off, because you're going to have loads on in the house. If you've got lots of charging source, okay, you might turn off the in phases a few times. No big deal. In phases turn on and off, you know, probably 50 times every single day. So now, did that answer the question?
Yep, they got it, thanks.
Oh, good. Yeah, it seems more complicated than it really is. But let's talk about AC coupling a little more. Let's see. Let's go here. In fact, here's one of the Schneiders. Schneider's a nice inverter. I would say it's the second biggest bang for the buck. Just my own personal opinion. The Magnum is the biggest bang for the buck. With the XW, you get more features, you get more power. Therefore, it costs a little more. This is designed to go with 6,000 watts worth of grid tie. You don't want to put 10,000 watts of grid tie inverter into this because it's not going to hurt it thanks to frequency shifting, where it would hurt it if it was an Outback or a Magnum. You have to understand that concept. Even with an SMA, which does not do frequency shifting. So this is actually pretty safe if you over solarize this inverter because of frequency shifting. Well, that's not exactly true though, because if you got, let's say you got 10,000 watts going into this thing, the transformer is going to heat up too much. You won't overcharge the battery, but yeah, you're going to get this thing really hot, and then I guess what happens at that point is it shuts off, because they do have temperature sensors all over the place. I would not advise going more than 6,000 watts on a 6,000 watt XW, or 4,500 watts on the 4,500 watt XW. That lends itself really, really nice to some grid tie inverters, because there are a number of 6,000 watt grid tie inverters over there or out there in the market. Or you can just tap off 6,000 watts of in phases Works great, especially with the Magnum. That really works well, because Magnum's a 4,400 watt inverter. You definitely don't want to go more than 4,400 watts, and sometimes they recommend only 4,000 watts. So you just peel off basically one string or two strings of in phases, whatever comes up to be 4,000 watts. That works out very nice. The rest of it stays connected to the grid, and those in phases would actually go dead when the utility goes down. Only the 4,000 watts worth connected to the Magnum or XW here would stay charging during a power outage. Now, if you want more power, here's 2 XWs. And I believe the question was from somebody that has the same exact type of system here. Good for 12,000 watts because they're both 6,000 watt inverters. You don't need any auto former with the Xantrex or Schneider like you do with the SMA. It's a pretty elegant little system. It actually does ship with backplates on it, by the way. We're not showing the backplates here, but they do come with those. So it's really easy to mount to the wall. There's holes all around the perimeter of our backplate, so you're going to find some studs on there. Make sure your studs are capable of supporting, 150 pounds or so per inverter. There's Magnum. We do quite a few Magnum AC coupled systems, again, because it's the biggest bang for the buck. It's a $2,800 inverter retail price. We do put the solid state relay in every Magnum AC coupled system because it does not do frequency shifting, and it will overcharge the batteries. It doesn't even know that it's charging batteries when the utility goes down and it's AC coupled. All the voltage and current sensing circuits on the Magnum, as well as on an Outback, are tied to the AC inputs. But of course, when the grid goes down, the relay disconnects the AC input. There's nothing going back and forth to AC input on either one of those inverters. So it just, since the grid tie inverter is hooked up to the output of the Magnum, they keep on charging because it thinks the grid is up. The Magnum doesn't know that it's charging because it doesn't have any sensing circuitry in the output like the SMA does. So you have to be careful not to go over the 4,000 watts because you're going to overheat the transformer and actually burn it up. That would kind of ruin your day. You don't need an autoformer with the Magnum because it's already a 240 volt system. And it is the least expensive AC coupled system. And if you're using in phases, this is typically the one that gets used. Just do a price. And it's $51.99, ships away in a crate. Here's a different way to do a Magnum. We do a fair amount of these as well. Not everybody has the garage space to put an AC coupled system in there. Well, we have this D3R battery box. It's an aluminum box, outdoor rated. I don't think we got it listed for outdoor rating, but it's a listed box.
Hey, Robin.
Yes.
Can I break in with a question?
You sure can.
Why do you not use 48 volt Magnum?
You see that bottom shelf that has 4 6-volt batteries there? Well, that one gives you 24 volts. We could be putting 4 12-volt batteries there and a 48-volt Magnum. That would not be hard to do. However, this particular size battery, and those are Concord 3050Ts, 305 amp hours at 6 volts. If you use 12-volt batteries here, you're going to be limited to golf cart size batteries or group 31 batteries. Those are only like 100 amp hours at 12 volts. Where when you put 2 of these batteries together, you get 305 amp hours at 12 volts. So it's just sheer capacity. And we can't put a 12 volt L16 in there because the box isn't big enough for it. So you'll get more runtime. You get more battery capacity on the 24 volt series. But you certainly could do 48 volt. If you could find a 48 volt battery about the same size as those, that's going to be a way better solution than 24 volts because the 48 volt inverter is going to be more efficient. They're usually about 2% more efficient. Did that answer it?
I believe that did answer it. Now we've got a few other questions. Does Midnight plan to support AC coupling with their upcoming inverter?
Oh, absolutely. Here's what I envision, and of course it's still a long ways away, for a Midnight inverter. Think of every feature any battery-based inverter has ever had, and add a few more. That's what this inverter will be, and that's one reason why it takes a long time. Ours will be a high-frequency inverter. All the other battery-based inverters out there right now are transformer-based. You know, they're heavy, and we won't be doing a heavy transformer-based inverter. Because of the fact that it's high-frequency, we're going to have plug-in cards. So my goal is to have a 6,000 or 8,000 watt inverter the size of a toaster oven, has the E-panel built in, and it can be repaired while it's running by a 10-year-old kid. I think it's all possible, but it's going to take us a few years. More questions?
At this point, there are no other questions.
Cool. We'll get on with this. Anyway, so this is a complete system. Doesn't use the E-panel, but you've got all the same kind of switch gear, AC bypass. There's even a GFCI outlet there, AC input disconnect. You've got 3 breakers over on the right-hand side that can be used for load circuit breakers. So if you only want to back up, let's say 3 circuits in the house, you don't need a separate sub-panel. It's built in. We do use the Magnum router. Actually, Bobby designed the original version of that, my brother. It could be done with a 48-volt system. I'm not sure what batteries you're going to use, but it makes more sense to use this and to use a battery about the size of a Concorde. The Concorde is what this whole entire battery box was designed around, by the way. And this is an outdoor box. In fact, I think the next picture, yeah, here's the same exact system in California someplace, mounted on a nice concrete pad. It actually looks quite nice, doesn't it? That's the same system. So what was the price of that? Let's see. $67.49. If you want to do the E-panel version, it's $51.99, but you still got to do something with your batteries. So $5,200 versus $6,750. You know, we're kind of like Burger King. Have it your way. It's just another way to do it. We build a fair amount of these boxes, and we used to put Outbacks in them too, but we don't no longer buy the Outback inverter. It's still a fine inverter. They just got too difficult to work with for us. We put a lot of magnets in here because they fit very nice. And by the way, if you want to get all the parts and do it yourself, all the mounting holes are there on the shelf for an Outback FX or VFX inverter as well.
Hey, Robin.
Yes.
I'm going to unmute somebody for a question.
Oh, okay.
Okie dokie. Go ahead, Kim. Hey, Kim, you there? I unmuted you.
I'm here. Can you hear me?
Yep.
Yeah.
Okay, I had myself muted. Hey, Robin, can you explain why we use a triac in the Magnum AC coupled 24-volt system? I think that's why we weren't offering the 48-volt. Isn't that correct? So the batteries didn't get overcharged?
Well, that's part of it. We could overcome that. The triacs that we use, actually solid-state relays, now it's a triac, cannot accept more than 30 volts input to turn them on and off. So if you're using a 24-volt battery bank, that works very well with the solid-state relays or triacs. Going to a 48-volt battery bank, the inverters make perfectly good sense, and we would have to do something to limit the voltage that turns on and off that solid-state device. And that can be done, and we have done that in the past. It just gets more complicated. The 24-volt system was a slam dunk, easy, and you don't break these $200 triacs by screwing up.
The other thing, Magnum for AC coupled, they don't recommend more than 95% of the rated solar array on input. So like at a 4K, they want no more than like 3.8K coming into it for AC coupled.
Yeah, well, for AC coupled, you'd want to use the 240-volt system, and that is a 4024 on the 24-volt. So it depends on who you talk to at Magnum. I've gotten this both ways. They say, some of them, they say you can run it right up to the maximum of 4,000 watts, and some of them, they say 95. There's no reason to cut it down to 95. Maybe they're just worried about actually the array putting out more power than what it was rated for.
Okay.
I want that array. That's hard to find that. But as long as you really don't go over the 4,000 watts, the transformer is rated for that, and you're not going to overheat it. So they're just playing it a little safe, and I can't blame them by saying 95%. So in the case of our system, it's a 4,000 watt system, whatever 95% of that is. You said 3,500 watts? 4,000?
Yeah, 3.8 kW, 38.
Okay.
It's 3,800 watts.
And that's typically going to be an in-phase type of system, because I don't think you can buy a 38, maybe you can buy a 3,800 watt grid tie rig. I guess I'm not sure. There probably are some out there. Any more questions? Okay. Off-grid systems. We'll go through this quick. They're very similar to AC coupled. These are virtually identical to the battery-based grid ties, so I didn't put any slides in a grid tie, because they'd be the same slides we're looking at. By the way, a lot of people do not know that the Sunny Island inverter is actually UL listed for grid tie, just like the Outback is and the XW. They don't really market it as such because, being German, they want everybody to AC couple. Here in America, we DC couple or use charge controllers. So this is an off-grid system, very standard, 120-volt system. Both Tom in Hawaii and Ryan in Maine have this exact system. They also have a bunch of other systems as well. But they both really like the Sunny Island. It is the most rock-solid of all inverters. So your lights are not going to flicker. That's one of the downsides of using a Magnum. The regulation isn't as fast as it is on the Sunny Island because they don't have as many transistors in there. And you will see the lights flicker once in a while on a Magnum. But also, you're not paying as much money for a Magnum. So this is like the Cadillac of an off-grid system. It's only 120 volts. You can, of course, add the autoformer to get a 240-volt off-grid system. Before we get to the rest of them, I wanted to explain two things that you get when you get the classic charge controller. The classic is by far the most sophisticated charge controller in the world. This is one of the things you get when you get the classic. It's called the local app. You also get the Whiz-Bang Junior, which now works with the local app as well. The Whiz-Bang Junior is a battery status monitor like the Outback FMDC, the Magnum BMK, except ours comes for free with the classic. If you want to buy a Whiz-Bang Junior for, let's say, the kid, the retail price is only $59. And by the way, it's more accurate than the other guys because it mounts right on the shunt. So there's no twisted wires to pick up noise. This is just 3 of the graphs that you can get with the local app. This is two-way communications. You can be sitting on the beach in Spain with your laptop computer, calling up your mountain cabin house in Denver, up in the mountains, and you change your battery charger settings. You can get all the data, so what your batteries have been doing. It is full two-way communications, and it's free. Here's the other free application. This is called My Midnight. It does log 11 different parameters when it's hooked up. The local app monitors, I believe, 6 different items, and it does log them for 380 days. The My Midnight here, which is a plug-and-play software, is only logging when you're connected. However, it can pull information from the classic's memory. And you can only display 3 things at a time on My Midnight, but you get to pick and choose what those 3 are. And this is very, very simple to use. Even I could hook up a My Midnight and make it work. I'm not sure I can hook up a local app because you got to do this thing called port forwarding, and I'm lazy, so I would actually use this one. I do use this one. But both of these are free softwares. No one else has software, remotely like either one of these, to tell you the truth. Certainly not for free. Okay, back to off-grid again. 6,000 watt. Oh, I thought we already covered this one. Okay, so here's the dual SMA 12,000 watt system. This is really a nice deluxe system. Comes with 2 classics. Retail price $20,000. Okay, it's not cheap. You can get it with the classic 200s or the classic 250s. It doesn't add a lot of money to go up in voltage on the classics. One thing you want to be aware of is just because the classic can have a higher number, like a 200 or 250, doesn't mean it's the bigger, better unit. No, it's higher voltage input. And you only want to go to those higher voltage units if your PV array is far, far away from your battery bank. And I always say up to 100 feet or so away from the batteries, use the classic 150. It's the most powerful, it's the most efficient, and it's the cheapest. Same price as the classic 200, which is also very powerful, by the way. Classic 250 comes quite a bit down in power, and it does cost more. So unless you're going to be hundreds of feet away, you want to use the classic 100 or 150. And you can configure these on our website for whatever you need and come up with the right part number. Here's a Schneider XW, single XW. This is a really nice off-grid system, $8,900. Again, you can configure it for any of the classics. Here's a couple of them. Same thing as off-grid. The only real difference is we added the classics. Other than that, these are pretty well identical. Now here's a new one for Schneider, the SW, to take off on the old Trace SW name. These inverters are actually rated at 3,500 watts. They call them a 4024. And they'll do 4,000 watts, but not continuously. Well, that's not how you run inverters anyway. These right now are available in 24 volts only. I don't think I'm allowed to say that they might come out in 48 volts someday, so I won't say that. This is a pretty nice little system, $5,160. This is a rock solid inverter. Tom has one of these in Hawaii. Can't remember if Ryan has one. Yeah, I think he does, actually. Lights don't flicker. It's simple to operate. It's a nice, inexpensive inverter. Schneider came out with this inverter to go after the Magnum Energy PAE inverters because, frankly, Magnum was just cleaning their lunch in the RV market. So they're trying to regain some of that. And because of that, we now have a new inverter in the AE market as well. And this is Doug Andrews designed this sheet metal for us for the SW. Here's a dual. This one comes with 2 classics, 2 inverters, $9,500. Here's the Magnum. This is the off-grid system we sell the most by far. This is probably a 10-to-1 over any other off-grid system. And why? Well, because it's the biggest bang for the buck. It's got all the bells and whistles you need. I can actually operate the Magnum remote control. Don't ask me to operate the Outback Mate, even though I helped design it, because I can't do it. But the Magnum remote, you never even have to pick up the instruction manual. You just start turning the dial and pushing buttons. It is so intuitive. They just did an incredible job. These systems, every one of our systems come with lightning arresters. They now all come with whiz-bang juniors. This one doesn't show that in there. It actually shows the Magnum BMK. And for those of you that want to have 2 battery status monitors, we designed the kit where you buy a whiz-bang junior to be able to hook up both a BMK and a whiz-bang junior at the same time. Here's another one of those Magnums. This is a fairly recognizable face. In fact, Kim actually came from Hardy Diesel years ago. Kim's from Hardy Diesel originally. And I don't know how we ended up with this picture, but we just did. Here's another Magnum system. Very small system based on the MM. Nice little 1,000-watt sine wave inverter. We can even do the, I think it's a 12 or 1,500 watt modified, although we don't do many modifieds. Comes with classic, comes with a couple of lightning arresters. Fairly inexpensive system. So that's the retail price of $3,549. That's getting to be pretty cheap for all the stuff that you get. Here's these days, since we don't actually mount the Outbacks, we do everything else for you. So all you got to do is bolt the Outback FX or VFX or GVFX inverter to the E-panel. Everything else is wired in. So you have the 2 battery cables to connect and then 3 AC wires. Very, very simple. Takes you about 10 minutes. And because there's no inverter on here, this is seems really cheap, $2,300. Of course, you do have to buy the inverter to go with it. Here's another way to do Outbacks, the Radians. This is a big system. We actually have an AC bypass that can handle 2 Radians. Outback, I don't think, can do that. And this thing on the bottom is the battery combiner. So it's good for 1,000 amps. It's got some massive bus bars inside. You can actually add more of the 250 amp breakers in there if you want. Again, you buy this, it's all pre-wired. All you do is you add on the 2 Radians. It ships out in a big crate. Something else that you're going to have to do soon, there's only one state right now enforcing NEC 2014. July 1st, I think there's 16 more coming online. And by the end of this year, there's going to be 21 states adopting the NEC 2014. So you're going to have to be able to disconnect the grid or the battery-based inverters. And that's what this does. What is this? Network connection difficulties. Rachel, can you hear me?
Yes, I can hear you. No problems.
Good. I'm not sure what this little sign's telling me, but anyway, okay. Let me turn this thing off here that just popped up. Dum-de-dum. Oh, I don't want to do that. Okay. We've got a gray version of the birdhouse. This is something that's going to hit everybody in the industry. Get ready for it. It adds a lot of money to the system. It doesn't make the system work any better, but due to NEC 2014, we're going to have to be able to shut off the entire PV system with one flick of the switch, in which case this is our birdhouse. It'll shut off grid tie inverters, it'll shut off generators, it'll shut off a battery-based inverter. We have many different ways to shut off anything that you have to do. And a little wiring diagram of how a whole system could be hooked up. So over here, your solar array, you've got to have a disconnect within 10 feet of it. It has to be able to be shut off from something like our birdhouse. If you've got a grid tie inverter on the system, the capacitors inside the grid tie inverters, for the most part, will stay charged for as long as 2, 3, 4 minutes. You've only got 10 seconds to shut off the juice from the grid tie inverter, because otherwise it's going to backfeed the wires all the way down to the utility. Well, another way to take care of this is to add another one of our switches right next to the grid tie inverter. And so when you push the red button here, it's not only shutting off the PV array, it's also shutting off the juice to the grid tie inverter, so it can't backfeed the wires. It's the wires you're trying to make dead within 10 seconds. If you have an AC coupled system, there's going to be a battery-based inverter. We have a little board that goes inside of the E-panel here that also shuts off the battery breaker to any of these inverters. It doesn't matter what brand the inverter is, we can shut that off. And here's a different little breaker we have that can shut off a generator. If there's a generator involved in the system, firefighters don't want that generator coming on when they pull the meter off of the wall. Well, a generator's job sometimes on these systems is to come on when the power goes out. Well, the firefighters don't want that, so we can make sure that doesn't happen with the birdhouse. That's it for that. Now let's go really quick to our website. Move this. Let's find our website here. Here we go. So this is covering some of the systems you saw on the slides. Let's just pick one here. Is a Sunny Island system. So if you click on this, this is the model number, SMA off-grid. This is the kind of thing that you'll see. It gives you a description of what you get. Then it gives you basically a mini parts list of all the major components. So it has the Sunny Island autoformer, it's got the E-panel, an AC bypass assembly, classics, SPDs. Down here it gives you more model numbers if you wanted 2 classics or a different classic. It gives you the prices and it gives you the model numbers, so it makes it really easy to order. And here are some options. Something I didn't talk about was our new communications adapter. This allows the Classic to communicate directly with the Sunny Island. So you know how the Xantrex or Schneider has their own, they can talk, the charge controller talks to the inverter system, and you get the readouts on them. The remotes, same thing with Outback. Now you can do the same thing, but we are SMA's charge controller. And since they're CAN bus and we're Modbus, we had to develop this communications adapter. And basically what happens is the SMA inverter takes charge of the charge controllers. So when you set the bulk and float and EQ and all that stuff on SMA, you have automatically set it on the Classics too. Up to 4 Classics can be connected to that system. Here we're recommending surge arresters. Of course, you wouldn't need them on the pre-wired system. They come with it, but you may have other things you want to protect. Battery monitor. This is a very, very simple voltage-based battery monitor. Here's some battery boxes, some battery cables. They're overpriced, but they're really nice. I think we use the X-Flex. Yes, we do. Some of the battery cables out there that are real cheap, they're using Chinese wire. It's not all pure copper sometimes. It's not UL listed, and you may have inspector problems. So keep that in mind. Like I said, our battery cables aren't cheap, but they meet all the code requirements. Here's just some combiners.
Robin, can you hear me?
Yes, I can.
Hey,
Yes, go ahead.
I just want to let everybody know out there that if you want to have a webinar just going over our website, I do it in like a half an hour and we can go over everything step by step, and I can let you know how I use the web and how to find things really quickly. So anybody that's interested in that, just let me know, just email me, we'll set up a private webinar for your team.
Perfect. I'm certainly not an expert on our website. Let's look down inside of this dual XW. Again, you've got a parts list, you've got a description. Here's more part numbers for different configurations. By the way, one thing I would like to point out is videos for virtually anything you need to do with Midnight products. We do have a ton of videos we've made. I don't know if you all have watched any of our videos, but these are all things that Ryan and Tom and John and other people have made. I'm going to show you one right now. It's a very quick one, arc fault test. This was done, gosh, years and years ago before the Classic was in the market. We are still the only charge controller in the world that has an arc fault detector built in. I'll show you how this works here. This is Bobby talking, I believe. He designed the Classic. That's about 160 volts DC. Yeah, so that will start a fire. That will not start a fire. So that's how effective the arc fault detector is on the Classic. It works very, very well. And that's the only one there is. 2014, again, arc faults are required, but since charge controllers are normally used off-grid and a lot of those are not inspected, it hasn't become a big deal. There are more and more localities that are requiring arc faults on off-grid though. And as of today, you're going to be using a Classic if you got to have arc fault, because it's the only thing there is. We did not put it on the Kid because, like I said, a lot of people don't care about it. We do also have a ground fault detector built into the Classic, which I really have very little use for. They don't stop fires, but arc fault detectors do stop fires. Okay, let's go look at a different. That's just man. There's a mess of different pre-wired systems that we offer, and the guys that build these, a couple of the guys have been here for years and years building these systems. Here's a big one. If you want a quad stack, and believe it or not, we do sell quad stacks. It'll ship out in 4 crates. I don't know what else to tell you about pre-wireds. It makes your job easier because they do get tested. They get crated up. You have less hassles from inspectors. We do have staff, Ryan and Tom, that will answer the phone anywhere from 7 o'clock in the morning East Coast time until 5 o'clock Hawaii time. These are professional installers. They can answer your questions. And they've installed virtually all the gear out there, not just Midnight products. Are there any other questions?
We do have questions.
Okay, all right.
Is there a communications adapter coming to interface between the Schneider CommBox Modbus and the Classics? Again, I have a dual XW with 2 Classic 200s and would like to see the CommBox be able to see and monitor the Classics.
As time allows, we're going to revisit that. Originally, we designed our communications adapter for this SMA to be able to accommodate the XW stuff as well. However, SMA gave us the protocol which saved us about a year's worth of reverse engineering so that we can connect up to it. Schneider has just recently given us something that may allow us to do that, and it may not be any better than what we got from them before. They're a little more protective of their code in the interface because, of course, they have their own charge controller. So the answer is I don't know. It's a matter of we need to spend some time, and right now the engineer, Jim, who was doing that, is on another project, a rapid shutdown project. I would like him to get back and look at the newest information that we were given by Schneider to see if we can adapt that thing. It's still a lot of work. I don't know that we would ever recuperate our engineering costs. If you go into Intersolar in San Francisco, Jim will be there. Twist his arm. It's just a matter of time and how much work we have to put into it. We do have an interface to Outback, by the way, right now, which is their AXS. You can buy their AXS for like $179. It replaces the Mate, or the Mate 3. And you can connect up over the web a Classic to the Outback stuff, or numerous Classics. It's funny that Outback doesn't actually offer any software or firmware to go with their AXS. They expect you to write your own Modbus software. Well, we did that, and rather than just turn it over to Outback, we wrote it such that you have to have at least one classic in the system before it will talk to the Outback system. But then it does, through your computer, your screen on the computer, you can be marrying up the classic to the Outback stuff. But so far we cannot do it on the XW. More questions?
At this point, there are no more questions.
Okay. It took almost an hour. Usually I run way over, so this actually worked out quite well. I would like to invite you to check out our pre-wired systems. If you're not familiar with battery-based stuff, by all means, learn it by buying a pre-wired system. You'll learn the ropes. You'll see what's important, what's not important, and you may decide to do your own after that. But if you've never done a pre-wired before or a battery-based system, the pre-wireds are a good way to go because it just takes all the guesswork out of it. I guess that's about it, Rachel.
Alrighty, very good. Well, thank you everybody for coming.
Yes, thank you very much. What are we doing next Wednesday?
Next Wednesday, well, we were going to kind of cover some of the AC coupled systems some more. Probably going to get with Ryan and see what else we might have in store as well.
Yeah, he'll cover that much more in depth than what I did.
Yep.
So good.
Well,
all right.
very
Well,
good.
thank you. We'll see you all next Wednesday, maybe.
Thank you, everyone.